Determine the interval where y equals x over x squared plus 2, where x is in the set of reals, is increasing. The function is increasing when the derivative is positive, so we must first find the derivative of the function. For this function, we will use quotient rule to find the derivative. So y prime is equal to the derivative of the top, which is x, times the bottom, which is x squared plus 2, minus the top, x, times the derivative of the bottom, which is x squared plus 2, all over the bottom squared, x squared plus 2 squared. So now we simplify. We first find the individual derivatives. So the derivative of x is 1 times x squared plus 2 minus x times the derivative of x squared plus 2, which is 2x, using power rule, all over x squared plus 2 squared. Now we distribute out the brackets. So we have x squared plus 2 minus 2x squared, all over x squared plus 2 squared. Then we cancel out the x squares. So the x squared and the negative 2x squared cancel out to be negative x squared. So we're left with 2 minus x squared over x squared plus 2 squared. And this is our derivative. For a function to be increasing, the derivative is positive, so we set this as greater than 0. Because the bottom is a square, and a square is always positive, we can cancel out the denominator without worrying about the inequality. Now we have 2 minus x squared is greater than 0. Move the x squared over, and we have 2 is greater than x squared. We take the roots of both sides, and that turns into root 2 is greater than root of x squared, which is equal to root 2 is greater than the absolute value of x. So when the x is positive in the absolute value sign, we leave it all as is. So root 2 is greater than x. But when the x is negative in the absolute value, we times everything by negative. So we have negative root 2, and because we're timesing by negative, we swap the inequality. It's less than x. So our interval is negative root 2 is less than x, which is less than root 2. So our interval is between negative root 2 and root 2. And that concludes this lesson.